Chapter 15 of the Ray Tracer Challenge is where we enhance our ray tracer to use all of the power of 3D modeling programs with the introduction of triangles. We start by creating a single triangle ray object. It's composed of exactly 3 points and 2 edges. The edges go from point 1 to point 2 and point 1 to point 3. Direct access to the points is not allowed since the edges depend upon them and must be updated whenever they are changed. The cross product is used with the 2 edges to produce the normal of the triangle. Once again, if the points are changed, the edges must be changed and the surface normal recalculated. The first test makes sure the triangle is constructed properly, which uncovers a deep problem in my programming. Somewhere along the way, I messed up my equality checks for the base class of both points and vectors, the tuple. Here I check the point to see whether it is null before moving on with the calculation, and this doesn't agree with how I structured my equality checks. In my not equals operator, I have to check to see if it's equal to null, which calls the equality operator on a tuple. I then have the equality test on a tuple inside of my equality check, which causes a nasty loop. I cut out the equals operator and not equals operator and just go with the equals method. I'll be back later to fix this mess, don't worry, but for right now I move along. I add a method to get the normal and the first test passes. For test 2, it's time to bring the triangle into the ray object family, which means implementing several abstract methods. Specifically, we're looking for the normal method to return the calculated normal so that the ray tracer engine will have access to it. However, I skipped this test as it really makes no sense for me to implement it with the way I program things. Test 3 is where we start intersecting by missing the triangle with a ray that's parallel to the surface. The intersection method, which is going to be called by the engine to determine if the ray has struck it or not, is updated to include just enough code to know how to handle a parallel ray. No intersections are made, and an empty list is returned. Now we have a test concerning the edges. This ray will hit the plane that the triangle describes, but it's going to miss the boundaries of the edge. This math is going to be very important for us to implement, especially the u and v variable. These 2 variables are used to interpolate values across the surface of the triangle. U's range within a triangle is going to be between 0 and 1, so if we exceed that value, we haven't struck the surface. My test doesn't fire off, so I check chapter 1 to see if something's buggy, and I notice normalization isn't working. Remember how I was messing around with that equality? Here it is popping up again. Now, I've got an infinite loop happening where I check for equality within equality. I'm really not paying attention, I'm just trying to get this chapter done with. Give me a few moments to see the nonsense I'm doing and eventually I'll work it out. I look up the solution online and the recommendation is to use the object reference equals to make sure things aren't null, and then just to use the equality method I have to determine everything else. I simply not the equality method for having the not equals operator, and things work just fine. Now it's time to finish missing the triangle. So far we did the U coordinate, now we actually need to do the V coordinate. All of these results should return nothing. Now the interesting part, a ray that actually strikes the surface. Unlike many of the other surfaces, striking a triangle will only return one intersection point, since it's really just a plane with limited boundaries. Describing triangles one at a time would be a major pain. I've done it before. Try laying out even just a simple cube. Therefore, the book guides us with implementing an object or OBJ parser. First, we create the basic text file with some general gibberish. A stream reader is used to load the file and iterate line by line until the file is over and then closed. Each line is split using spaces. Each line begins with a command, such as a V for vertex or F for face. Testing doesn't quite work here, because I'm not in the correct directory to find the OBJ file. I changed the string to raw mode so that I don't need to worry about escape characters, but that's not the real problem here. With a little web searching, I discover a few ways to access the current working directory, which isn't where I actually want to be. There we are. That gets us to our current app directory to find the object files. Here we're going to read an object file with some vertex data inside, create the points associated with each vertex, and then use them to generate a triangle. I create a list that is going to hold the points inside the OBJ loader, so that as we parse things line by line, it will continue to add them vertex by vertex. The vertices are not ordered in any way here. They are just a list of every point used in the object. The object is later constructed using the face command, or the F, which tells you what vertices to use to create each triangle or polygon. Vertices are composed of 3 floating point values, and faces are composed of indices that tell you exactly which of the vertices in the list to use. The next test involves processing faces. In an OBJ file, indices start at 1, so you'll see me using offsets of 1 in my code since I'll be doing everything 0-based. A simple face has 3 indices listed after it to create a triangle, but it could list more and create a polygon. I create a group to hold all the triangles. I also trim any excess white space off of the line so I don't get any extra elements that are blank. I check that the length of the line is 4, 1 command and 3 indices. Each element is then parsed into an integer and used to create the triangle. This is all done in a try-catch block in case things go wrong with parsing. I also make sure that the indices are valid by checking that they are smaller than the number of vertices in my list. This way I won't get out of bounds index exceptions when accessing the vertex list. Now I just need to make sure that all the triangles are added to the triangle group inside the loader. Another test passed, but that was for the simple case where the 3D model has been triangulated. It's possible that the model has faces which are made up of more than 3 vertices. The book has us assume that the faces will be no more complex than a convex polygon, so using a triangle fan splitting technique will work in breaking them into individual triangles. A triangle fan method takes in a list of vertices. A triangle fan is just a set of triangles where each triangle shares one point and they fan out from that central location. They are used to create the tops of polygonal cylinders. To create the triangles, just use the first vertex in the list as the start of each triangle, and then use the next 2 triangles to create the opposite side. I had to remember that I'm using indices here and not actual vertex values, so I need to pass the indices into my vertex list to get the actual points in 3D space. Once processed, the triangles have their parent set. I'm doing this outside of the create triangle method because I have a feeling I'm going to need to be able to change what group a triangle is under as I process things. It's a hunch I have that's proven right shortly. Silly mistake here, I've got the ordering of the points wrong. We can move on. I jump the gun and make a simple model in Maya to make sure my OBJ importer will work. Object files can contain a group command, which will split the triangles into individual groups, which hopefully will help us with our axis-aligned bounding boxes and make rendering a little bit more efficient. I make the loader have a group called root, where everything will start. Any groups discovered in the object file will be created and all triangles placed under it. Each of those groups will be parented to the root group. And now's the time we've all been waiting for. Loading a 3D model from an external program into the ray tracer. I noticed there are a lot more features exported than I support, so I go back into Maya and turn off normal, smoothing, materials, and point groups. However, even then, texture coordinates are exported by default, and they introduce a / to denote the different parts in a face command. That's something my parser didn't take into consideration, so I need to go back and split each parameter by /, and then use just the first element of the split to get the vertex index. I forget to implement the local bounds of the triangle object, which is required to calculate the axis-aligned box. I iterate over each point in the triangle, determine the minimum and maximum coordinates in the x, y, and z, and return the bounds. This is something I should really consider pre-calculating for performance reasons, especially with thousands of potential triangles. Maybe later. I'm getting an invalid number of vertices warning, and this is because I stupidly forgot to put it under the else part of my if statement. Everything is actually processing just fine. Took a while to process, but when it was finished, I get what looks like the bottom of the box. I look over the vertex information in the file to see what the scale of my object is at, and I notice values that are in excess of 90. I use a scale matrix to reduce the size of the object and give it a 45-degree rotation so I can see it on an angle. Huh, still nothing. Let's scale it down in Maya to see what happens. Okay, I see something now. I wonder why my transforms in the ray tracer don't work, and I check the intersect method and notice I never transform the triangle by the matrix inverse. There's a little nub of a box at the bottom, but why is there a second untransformed box above it? At this point, I think I've got something deeply wrong with my groups and how objects are being rendered. Since so many changes have been introduced over the last few videos, I go back and decide to rerun my tests and see if anything fails. Plenty has gone wrong with Chapter 10, but this is an easy fix. Just need to reference the pattern at any random point, since this is a solid color and will always return the same thing. Now something to do with the lighting of the pattern's a problem. Once again, this is an easy fix. Turns out I wasn't multiplying the ambient term by the pattern's value. Next is the test pattern, and it seems that I'm just not multiplying by the matrix inverse. Simple fix. Chapter 11 is next, and it looks like I'm having an issue with the last few parts. As I look at the code, I realize I'm grabbing from the list of all ray objects in the scene, and the first one is always the root group. Changing to grabbing the root's children solves this problem for the next few tests. The value here is so close to what the book recommends, I'm really not going to fight it. I'm just going to let it be. A previous refactoring of the intersection object caused this next issue. All I need to do is reference the intersection point to fix things. Something's wrong with the normal calculations of a cone. Turns out I never did a check in the vector normalize method to make sure I'm not dealing with a vector of zero length. This produces a not a number error when I divide by zero magnitude. So what I do instead is I just return a zero vector. Well, you know what? It wasn't my code. For some reason, my root is null. A quick initialization in the scene fixes that problem. And there's our cube again. I think I lost some footage here, because I'm almost positive I remember going line by line through my scene and changing how the renderer worked. I made sure that I was using my hierarchy of objects for intersection testing, and not using the big old list of ray objects that I had inside the scene. At some point, I had been almost doubling the render time since I was processing every individual object in the scene one after the next instead of using the hierarchies that it was part of. Smooth triangles are up next, which means that each vertex can have a different normal, and we can interpolate between them over the surface of the object, which can give our triangles a smooth appearance, or really any appearance we want. We start out with a new class separate from triangle called Smooth Triangle, but it's going to share most of the actual code. Really, in a few minutes, I'm going to merge Smooth Triangle with Triangle into one class, since they kind of do the same thing. A smooth triangle expects to have a normal for each vertex to interpolate over the surface. I guess the notion of it being smooth isn't because we can average the normal, but instead because we're actually interpolating smoothly over the entire surface. But sharp corners are still possible between triangles. A big change to our code comes with supporting this interpolation. We now need to include the U and V calculations in the triangle intersection with our intersection object. For all previous ray objects created, these values will default to 0 and not be used. Here's the intersection class, expanded to deal with U and V values. This test is for interpolating over the surface. The getNormal method in ray objects now takes an optional intersection point, which is going to be ignored for just about everything except for triangles. And of course, there is some refactoring that needs to be done in order for all the child classes to accept this change. The local normal calculation for the smooth triangle uses the U and V values stored in the intersection to calculate the normal for that point. Now the rest of the renderer needs to be updated to handle these changes. The computations class now needs to pass the intersection point when it's preparing things. This is a mistake I make a few times where I forget to pass the intersection in the normal calculations, since by default it's just set to null. Now to include loading vertex normals in the object parser. Vertex normals have a command of vn, and are followed by 3 floating point numbers to define the vector. They are also accessed by indices when assembling the triangle. As you can see here, the face command actually can have 3 components: the vertex it's using, the UV texture coordinate if we were using them, and finally the normal index. I go through and handle splitting and accessing the first and third element. It's at this point that I think having a separate class for triangles and smooth triangles might make a lot of sense when you're writing a book, but doesn't make any sense for an actual renderer. I start moving over the code from a smooth triangle to triangle, adding 2 more normals. If not enough information is given to define the 3 normals individually, then I go ahead and calculate the surface normal using the methods we did for the simple triangle class. I'm trying to pass those triangle tests again since I made so many changes to my code, but there seems to be a little bit of a glitch here with the normal because it expects an intersection point. It's not a big deal. If I don't have an intersection point, I'll just assume I'm acting like a usual triangle and return the first normal, since technically all the normals should be the same. I expand fan triangulation to work with normals. Cubes are nice, but I really like to see my ray tracer with a more complex object. I bring in the head of my Foxy character from my Five Nights at Freddy's video series. There are way too many polygons, so I first try retopologizing the mesh, which crashes the program. I then spend about 10 minutes removing excess edges and getting the triangle count to around 10,000. I also export the object out as separate groups, hoping my bounding box algorithm will pick up on it and result in even more optimization. Right now, I'm constantly recalculating bounds for objects with each test, which makes no sense. I split things up into a pre-calculation step so that the bounds of all objects are calculated before rendering. If the bounds exist during rendering, we use it. Otherwise, we'll calculate it. Here's another issue that was slowing down my rendering. I was iterating over all the ray objects when I should have just been calling the intersect method on the group object, which would have automatically gone through all the children. I modify getBounds to check if it's already been calculated. Things still seem to be running too slow for me. I notice a section where I have duplicated code and remove the redundant part. I decide to let the computer do its processing. It takes a few hours, but it finally produces a render. It's not a gorgeous image, but it's what I was going after. Triangles and normals, exporting OBJs, everything seems to work. It's a great step in the right direction. It could definitely use some performance enhancers in the future, but once again, that's outside the scope of the book. And that's chapter 15. Even though we have one more chapter to go, this really felt like the culmination of the entire book for me. With nothing more than an IDE, a computer language, and this book as a guide, I've created my own ray tracer. One more chapter, everyone, and then we're finished. See you next time. So long and goodbye.